So when my boss, Kiyoto here, let me do the introduction, he told me that I wasn't allowed to give any fluffy stuff. And I looked at him seriously and I said, do I look fluffy to you? Right. So the whole notion of application development, if we think it over time, it's kind of studying the evolution of two separate problem sets. One is dealing with all the dependencies we have in our application or service that we're developing. If I write a service on Node and I deploy it, for example, on Amazon, I need to know what kind of supporting libraries it's going to roll with. If I deploy this application remotely, I'm going to need to make sure that the people are installing it with the supporting libraries. The other problem that I'm going to be dealing with is logging. Because a log coming out of one application may look one way, and a log coming out of another application may look another way, and it may be need to be formatted in yet another way to communicate with a third application. Unfortunately, in the course of this evolution, a few things have evolved to make all of these processes simpler. One is the notion of containers. How many of you out there are software developers? Okay, we got hands. How many of you are already working with containers like Docker? Okay, most of you. So you understand the problem that Docker solves. Well, what we're going to address is our integration with Fluentd. And Fluentd is a unified logging layer. It's being baked into Docker right now. And Kiyoto is going to explain more about that. So everyone give a big hand to Kiyoto Tamara.
Awesome. Thanks for the introduction. Actually, it touched on a lot of things I was going to say. So my already short talk is going to be even shorter. So first of all, how many of you are Fluentd users? It's great to see a couple of hands going up. How many of you have heard of it at least? All right, that's great. So today, what I'm going to talk about is a brief overview of what Fluentd is, what the common use cases are, and as John touched on, I'm going to do a little demo and explanation around our recent exciting integration with Docker, probably the open source du jour over the last few years. So a little self-intro. My name is Kiyoto, and that's the contact info for those who want to harass me in public. And I work for this company called Treasure Data. We provide analytics infrastructure as a cloud service, and we are also the founder and sponsor of this meetup. And a little embarrassing, but I'm actually head of marketing there. And when's the last time you want to listen to a marketer talk about software? But trust me, I used to code. I used to be one of the community leads for Fluentd. And I wrote some code, but mostly I read a lot of code, a lot of plugin code, and answered a lot of questions. In general, trying to be helpful for the Fluentd community. So I believe all of you have like smartphones, so tweet now. We need some like buzz. So I'll wait for you for like 30 seconds. Come on. Take out your phones. I'm going to do this myself. Okay, my client is way too hard to use. So what is Fluentd? This is the explanation that I came up after talking to a lot of people and trying to explain what it is. It's a data collector, and it's an extensible and reliable data collection tool. So for the first half of the talk, I'm going to go over what I mean by extensible and reliable, and what it really means to be collecting data. So it's a data collection tool, and why does it matter, right? When you look at the landscape of data analytics and big data and data engineering, everyone is talking about data processing engines and how scalable and robust their storage is. But all of that is moot without having a robust system in place to collect these data in the first place. Because if you're not collecting the right data, no matter what kind of processing that you do, it is going to be bogus. So this is a problem that we noticed early on in treasure data's life, and we decided to solve this problem once and for all. And what you're seeing on the screen is pretty much what happens in every organization as it tries to grow its data engineering efforts. There's a lot of scripts that are written by different people, some better maintained than others. And as you add more data sources in storage and processing layers, it gets exponentially more complex. And it has a lot of issues. First of all, there's a lot of care that goes into making sure that the code works right. Like, should I retry or not retry? If I retry, how should I retry? And also, in general, I need to figure out how to use Kiyoto. Messy code begets messier code over time, and your cost of maintenance goes up. And this is just like, forget about data processing. This is just about collecting data, taking data from point A through C to like Z, right? This is painful, so let's solve it. And Fluentd's goal is to be the data router, the routing layer for all the data sources and hopefully all the data targets that you have in mind. So data can be from Apache Access logs, Nginx logs, or it can be from application logs for your mobile apps. Or if you're operations folks, syslog contains a lot of information. And I just wrote down your system. Like wherever it is, all you need to do is write an input plugin, and you'll be able to send data to Fluentd. So once the data is in Fluentd, you can do a bunch of things there. You can make sure that the data is transferred properly by buffering to the disk. You can route messages based on tags. I'm going to go into these details more. And of course, you can do what I call the lightweight in-stream processing by using the filters. Then you send data to wherever you want to send the data to. MongoDB, MySQL, Hadoop, Amazon, Google, you name it. There are about 300 plugins today written by hundreds of people. And most of them are they have permissive open source licenses. So the second point is actually about that. It's really extensible. So from day one, when we decided to architect this system, we wanted the core to be very small and handle all the things that are annoying to handle, but very important to do. So making sure that you do all the buffering right and error handling is robust, and routing the message to the right place, because you don't want to send the data that you would want to put into a log table into a transaction table, for example, right? And also taking care of parallelism. Threading, multi-threading, all that stuff is very complex, but very important if you want to get high-performance systems. And all of that is taken care of in the core. And on the plugin side is everything that is specific to your use cases. So reading data from a particular data source, writing data to a particular data targets, and also formatting is taken care in the plugin layer. So one way to think about is common concerns are handled by the core, but specific use cases are done and delegated to the plugins. So here's a little detour on the architecture. This is a short talk, so if you're interested in the weeds of things, please find me after the talk. And it goes through this like really colorful boxes. So the data comes in through our input layer, input plugin. Then different inputs have different formats, so it needs to be parsed. So the parser is also pluggable. Then it goes through the filters where you do in-stream processing. And before you actually output to external systems, you need to make sure the data is buffered properly. Like if you're sending data over the internet to some third-party systems, the last thing you want to do is to lose your data in flight, right? And finally, different output systems expect different data formats. So you can format the data in the way you want and share that as a plugin. So one way to think of it is like the first half is pretty much like input-ish, and the latter half deals with outputting the data. So data sources and the data targets. So it's also very reliable. And when I say reliable, I mean in two very different ways. First of all, it deals with data transfer very reliably. Like a lot of times when you start collecting data from multiple places, you realize like 3 months into your project that you're missing like 10% of your data. And you don't want that because these are the 10% that you'll never get back, right? So from day one, you want to design your data collection layer so that it's very robust and hopefully handles data loss scenarios very gracefully. So our idea is basically we call it divide and conquer buffering. So in many systems, it's almost like all or none. You bulk upload everything in a huge file, and if it fails, like good luck, you retry again, right? But the thing about this is that a lot of times your data load is failing, not because the entire data is bad, but usually there's like a little thing to do with the encoding, or maybe one file is corrupted. But so in those cases, you want to make sure that you're uploading most of the correct data and have another way to handle and revisit the bad parts of it. So we have like this whole internal API about making sure that almost like viewing any data that's coming into Fluentd as a stream and making sure nothing is held back just because of like a bad part in it. Another thing is reliable process. And what I mean by this is a little meta thing because it's not just about Fluentd. But essentially, Fluentd encourages you to have a reliable data pipeline process. Again, like this is another rendition of the same problem that I outlined earlier. You have many data sources and many data targets because not a single data system is going to handle all of your concerns, right? But this as a process is incredibly unreliable. A lot of those scripts actually depend on each other often, and dependency is not actually bad if it's explicit. But a lot of those dependencies are implicit. And implicit dependencies really come back and bite you, especially when like a little things change upstream. Like let's say the data format changes. Your first script breaks, your second detail script that depends on the first one breaks, and by the time you're trying to fix it, everyone at the C levels are mad. And you don't want this. This is like the last thing that you want as a data engineer. And Fluentd really simplifies that process. Not because, part of it is because it's good software, but it really encourages this behavior of when I'm adding a new data source, or when I'm adding a new storage layer, when I'm adding a new processing step, it should not multiply our efforts. It might add, but it shouldn't multiply. So we actually call it m times n to n plus n. So if you add, like suppose you had 100 parts all moving around in your system. If you're adding another new service or another software into your system, it might add like 10 different integration points, but it should not create like 25 or like 200 new plumbing or endpoints that you need to update. So that's what I mean by reliable. So any questions thus far? Because I'm going to go right into the use cases. Cool. So I'm going to walk you through a couple of use cases culminating to the use case around Docker. But before Docker, there was Fluentd. And before Fluentd, there were logs and servers and all these databases, right? A very simple use case is just making sure that you have all of your file logs are in one or two storage systems. And this is surprisingly hard. Like when I worked in data engineering in my former life, we would write a whole bunch of script just to put the data into relational databases. And it's unreliable. And it's also very prohibitively expensive if you think about like the ongoing maintenance. And Fluentd solves this problem largely by you set it, you define a couple of regexes, extract the fields you want, output it to the system you want, and set it and forget. This, I would say, still accounts for the majority of Fluentd's deployments. And the beautiful thing about it is like something like this, you can get it to work in like literally like 10, 20 lines of configuration settings. So it probably reminds you of like pretty much any declarative config file. But source means how you register or add an input. And you specify its type. Tail means that you're tailing a file. And you specify the path. And you also specify the format. And another one, the forward, that basically means that you're using application logger for Fluentd to log directly to Fluentd over TCP. And once the data is in, you can actually output it to an external systems. And here you are looking at the example code to put it into MongoDB in the database called Fluent and a collection test. And there are many ways to configure. You can make the table or database names dynamic, and that probably requires like 10 more lines of code, but it's really not that much. Like if you try to do this on a like one-off ad hoc basis, every time you change any of this, you have to go and grab your code, and you figure out how to do it, make sure you test it, and that is not the path to go down. So the second use case is basically less simple forwarding, right? Like let's say you have a startup, and it starts to grow very much explosively, and now you need to add a lot more servers, and you need to collect logs from those servers. Eventually, like having like 1,000 servers like you're writing to a single database is going to fail. So you start to have multiple layers of like relay nodes in your logging pipeline. And Fluentd is really good at that. It's been designed into its core. So for example, like if the next relay node in your pipeline is unresponsive, or maybe it's offline, then you can configure like the secondary, you can configure the load balancing, and all of this is actually built into the plugin. And on the output side, like you can name it. Of course, we support our own backend, but you can also send data to Heroku, Amazon, Google Cloud Platform, and so forth. And the third one is actually my favorite. I see this a lot. It's called Lambda architecture. I don't know how fashionable this term is anymore, but how many of you have heard of Lambda architecture? OK, so it's a very fancy term for when you are analyzing event data. You need to analyze it for recent data quickly, but also with a high throughput for historical data. So a good example is you put the data into Elasticsearch for recent data so that you can visualize the data in dashboard and see how many 500s am I getting in my Apache logs in a 1 hour window. But at the same time, if you want to analyze all the historical logs and apply some kind of transformation to that, probably you want to use something other than Elasticsearch. And for those scenarios, you probably need another data store. So one of the key features of Fluentd is that it can copy data streams and apply different transformations to different data streams. So a lot of people first send data to Fluentd and have Fluentd worry about making sure the right copy of the data is in the right system. And again, the beautiful part is the code is really simple. So again, it's getting data from two places, application logs and server logs, API logs. And this time I'm actually using the copy plugin so that the data is written to two different data stores. One is Elasticsearch, and the other is Hadoop distributed file system. And I'm going to skip this one because I want to get to the more fun stuff. The more fun stuff is Docker. So when Docker first came out, one of the questions that I had as an evangelist for Fluentd is, how are they going to do logging, right? Because in the container environment, this old tradition of writing to the local file system doesn't exactly work anymore. The containers can come and go all the time. And even like once the container is gone, it's very hard to learn anything about what actually happened. So if it exits successfully, that's OK. But if it had an issue, if you had an outage in your Docker-based system, you probably want to know what was happening in the container before it died. So this problem was actually picked up by the Kubernetes folks, the container orchestration framework, spearheaded by Google. And what they noticed is that they can use Fluentd to tail a particular location in the host machine, or you can mount it into containers. Then tail that file, because it's one JSON per line, you can use the tail input plugin for Fluentd and send it to Elasticsearch. And I was happy that they actually added this to their example. Like, it's always a great feeling when a very popular project embraces you and integrates with you. At the same time, though, this is quite a bit of a hack because it's relying on this rather hacky interface of a container writing to the host, but the same volume is mounted onto another container that will be running Fluentd. And I've never liked that. So one of my friends and coworkers wrote adapter for Fluentd in Docker itself. So starting in version 1.6, which I think was released earlier this year, Docker now has this API called logging driver. And what it does is when you start a Docker container, actually, let me take a step back. How many of you are familiar with like running Docker's containers? Cool. So are you guys aware of logging driver? Cool. At least I'm sharing like a new piece of information. So what logging driver is that it gives the API for people to write against, and you can actually adapt your logging middleware to Docker. What this means is that when you launch a new container with a specific logging driver option, Docker container starts writing the data in that format to a particular location. So there's a one for syslog, I believe, and there's another one for Gelb, the gray log. And another option now is Fluentd. So this is going to go in production, I believe, in version 1.8. And you need to wait for 1.8, or you can build the bleeding edge and get it in. So by the way, I just got the first comment, but this thread is like incredibly long. It's like 50, 60 comments. That's the fun and peril of working with a very large code base. So do you guys use Kubernetes, or like am I the only person here? You should give it a shot. It's a very, if you're deploying Docker containers at scale, it's a very, very good tool. And we're pretty close to the team, and they've been very, very helpful people. Okay. It's surprising to find out that nobody in the audience has a smartphone, or at least not smartphones with Twitter clients. So the demo, I'm going to do a demo. Hopefully it's going to work. If it doesn't work, well, I shouldn't jinx myself. So what I'm going to do is not even as complex as this, but essentially the idea of using the Fluentd logging driver is that when you're using Docker in production, you would have like hundreds, if not thousands of containers running on one host. And when that's happening, the last thing you want to worry about is collecting all these logs and centralizing in one location and archiving it so that when there's going to be an issue in the future, you can go back and look what happened. But at the same time, if you're going to do Docker deployment in production, the first thing that you should worry about is making sure that you have all the logs. So I'm going to do a little bit of demo and show how it would work. And if you have any question, stop me anytime. So, is that like too small? Tell me when it's big enough. Okay, cool. Well, this is really. Okay, so I have like a Ubuntu machine running. So Oh, yeah. Should have made myself sudo. Okay. All right, cool. So it's saying like version 1.8 dev, which hasn't been released. So if you actually go to Docker homepage and download it, you get 1.7. But it's going to do this demo, I needed a 1.8. And that's why it says 1.8. So what I'm going to show you is the configuration file for Fluentd. And we at Treasure Data actually package Fluentd and maintain it. And we call it TD agent. And that's the version that I'm using here. And if you go to, this is what the configuration file looks like. So it is accepting data in forward format. And this is the format that Docker's logging driver use to stream data into Fluentd that's running on the host. And what I'm doing here is to match events with a particular tag, and the tag here corresponds to anything that has 3 parts, starting with the prefix td. And the type is td log. So what I'm doing here is I'm actually taking all the Docker logs and streaming into our backend service, Treasure Data. But you can do the same thing with like S3 or like any other storage system. You can put it, for example, in local file system, MongoDB, and so forth. So that's my Treasure Data API key. And this is one of the options where it automatically creates a table for me. And buffer type is file, like there's a couple of other stuff. So what I'm going to do is, this is already running, I believe, but okay, it's being restarted. And I need to launch a container, which is going to look a little scary. But so I am running a container with the usual option. And I'm naming the container test. But it really doesn't matter. So like, let's actually remove that. And this is the option that I mentioned, log driver equal Fluentd. So what it means is that I'm telling the container that I'm about to launch that it is going to log all of its logs into in the Fluentd format in the default port on the host, which in Fluentd's case is localhost 242.2.7. And another option for the log driver is the log opt option, where you can actually inline options that are specific to the particular logging driver. So one of the options for Fluentd is Fluentd-tag, which tells Docker to emit the logs with a particular tag. And if you remember from the config file, I configured Fluentd to send logs with a particular tag, the 3 parts starting with td, and that's what I'm doing here. So what this does with our current config is it is going to create a database in Treasure Data called Docker. And here I'm using the magic variable, and it takes the name of the Docker container as the table name. So this is actually, come to think of it, not the best way to do it, because if you have like 2,000 containers, it's going to have 2,000 names, but the spirit is here. Basically, it allows you to create this archive of Docker logs, but split by database, first of all, and table per container. And I'm using the base Ubuntu box, and I'm going to just like log into the show. So now I'm inside the container. So if I write like echo 100 to 100, echo, I am doing the demo, it should work. It should. So what I did was I just created a bunch of messages. And everything in the standard out is going into the host machine's Fluentd right now. So let's say, so I get out. And by default, Fluentd buffers the data. So right now it's buffering. but for the purpose of the demo to speed up everything, I'm going to flush out the buffer. By default, in our config, it's every 5 minutes. You can change it to like a minute, 30 seconds. Really, it depends on your needs. So it's being flushed out. So what I'm going to do now is go to our web app. And I have all these. Okay. Clearly, I wasn't doing that much work today. Console. Into our web app. Let's see. Cool. So this is actually Treasure Data's web app. Let me see if I can make this bigger. And you should be seeing the data here. Database, Docker. Yeah, so that's a great name. The database is called the Backstabbing Saha, because that was the name of the default container that Docker generated for me. And if you look inside, here's like a preview of recent data. It says like it should be working, it should really work, yada, yada, yada. So this in and of itself is still not useful, right? Because it's just taking whatever is emitted to standard error and standard out, and it's just like shoving everything into the log, the field. And that's fine, because when you're starting out, you're not going to do your log analysis on day one. But let's say your project goes well, there's like launch and you scale out. Eventually, you're going to have a lot of data. And whether it's us or not, like having a place where you can feel secure in the knowledge that all of your container logs have been aggregated and centralized is a huge boon to your future data scientist productivity and happiness. And here's one way to go about it. So that's pretty much all I have right now. So I'm going to go take questions.
Do we have, ooh, that worked. Do we have any questions? Who has questions? Actually, I have a question.
Sure.
I understand a lot of effort went behind getting Fluentd on Docker. What was kind of looking at this from a very broad perspective, what is kind of the vision behind it? I mean, I'm imagining different containers running, for example, different set of dependencies for different kinds of apps, and also different versions of Fluentd or different configurations of Fluentd. Can you elaborate a little bit on that vision and sort of tell us what this accomplishes? What do we gain from this?
So that's a pretty loaded question.
I'm sorry.
I think in many organizations, there's a lot of premature optimization when it comes to data engineering. And what I mean by that is, like, my background is math and stats, right? It's always fun to be working on the state-of-the-art algorithms, like making like some training algorithm like twice as fast. But what a lot of like data engineering and data analytics comes down to is counting things very carefully. And in order for, even if you are counting very carefully, if you're counting the wrong things, it really doesn't help. And one way to make sure that you're wrong is missing data. Like if you don't have all the data, you can't really count. So I'm sort of repeating myself again, but when Docker came out, naturally my first question is, like, this is cool, right? Like it really liberates application developers on one end and ops folks on the other end to stop worrying about this environment and distro dependencies and focus really on building apps. But you can't really, like even with that, you can't forget about like running and maintaining software systems. And if anything, I feel like Docker made it harder because things are not as permanent anymore. So that was the thought behind it. Unfortunately, I wasn't particularly good at Go, so I had to wait for my coworker or my community members to step up and do the integration. But now I'm happy because Fluentd has done a ton of work to make sure that it can get the data from many places and send it to many places. And Docker made it very easy for us to work with. So today, like, pretty much choose your own backend, right? So I don't know if that answered the question, but.
Well, it was deliberately a loaded question because I wanted to see if you like sort of went to different dimensions of the problem, so we could see it from different perspectives. Do we have any more questions in the room? Who of you are data scientists who have data
Actually,
engineering?
I have a question.
Oh, he has a question.
For those using Docker, how are you using it?
I have two Docker containers running, one running the app, one running Fluentd on a whole bunch of Amazon instances. And they're sending to a central cluster, which is like 3 big machines all running Fluentd as collectors, one in each Amazon availability zone. So pretend it's just one central machine. And that's sending stuff off to S3 and maybe Mixpanel and maybe MySQL or maybe other things. So this is a fairly elaborate.
So you're pretty happy about this feature? I don't know.
This is printing text spew, and I don't want to ship text spew around. I want to ship database records, which is the key value pair that Fluentd specializes in. Anyway, so that's one.
So you want to have some sort of like processing before thing, or if you have a parser JSON body, then that might be good. Like, if your application generates like JSON standard log, and then if you parse it, then consider it as a record, and it's raw data.
Yeah, Fluentd has that, and we're using that whenever it's possible. This is a big site with a lot of crazy applications made by people who no longer work there, so I can't control what the log lines are.
Right.
Okay, who else is using Docker out there and would like to share with us?
I actually can tell like a kind of interesting story. So we tried to use Docker for a very large gaming deployment, using it just as a application container for our app servers, but we had to abandon it. The reason we abandoned it is I don't know. It's something. I don't want to make it major, but the reason we ran to is that the Docker containers still have some limitations. Like for example, you cannot open. I don't remember exactly, but like you cannot open several ports. There is this port issue. We kind of ran like, as you said, like it was sort of like an implicit dependency. We didn't know it until the very last moment, and when we tried opening those ports, the containers prevented us. They blocked us. They could not do it, and we had to roll it back. That's what happened. But I guess the Docker will solve it, in future releases. But I have another question. So if you don't have Fluentd, for example, like say Fluentd doesn't exist, what do? You write code yourself for transformations, you write scripts, what is like?
Yeah, so Fluentd, the software, has its own users, but a lot of people that I've talked to, and I've talked to hundreds of people responsible for running data engineering operations, they end up creating something like that or going with other log collectors, because this problem arises in two ways. One is that of scale and the variety of data sources, right? You need to dump everything into Hadoop. Then ultimately you're going to write something that is robust and that can collect data from many places into many places. The other is almost like a hedge against software as a service. So a lot of those SaaSes have and encourage users to use SDKs. But what happens is that if you put data directly from the client into those third parties, you don't have access to your raw data in any efficient way. Some of them have export APIs, but even then it's not real time. So what they end up doing is they create like a data router sitting on the server side. So everything goes through their own servers or API server first. Then that actually like bifurcates the data and send it to like different places. So my answer to that kind of use case is use Fluentd. But as a concept, this idea of like event log collector and router is becoming like one of like the design patterns for data engineering.
Okay, who else out there is using Docker in their own data engineering efforts and would like to share with us? I hear crickets. I guess by that then we're kind of wrapping up the talking part of it. We'll be around for another half an hour or
Yep.
so. So
Happy
feel
to
free
talk. So
feel free to hit us up and grab some more food. And well, thanks for coming.
and before that, I forgot one more slide, which I'm going to present now. We are hiring. We're hiring for every department that I can think of. So please visit our careers page. And we also love referrals. So if you have a friend or friends looking for a new challenge and scaling a system with 70 billion events per day, we're the right place to be talking to. So again, thanks a lot for coming in, and I'll be around to chat more.
Thank you.